The Douglas B-19 heavy bomber is a classic example of a pretty common situation in aviation history. Back when the aircraft was first on the drawing board, the whole concept seemed absolutely brilliant and incredibly promising. But development and tweaking dragged on for so long. In an era of rapidly advancing technology, the airplane was practically obsolete before it ever took to the skies. Even so, the Douglas B-19 remained an incredibly elegant and truly impressive giant for its time. There's also a cool, lesser-known fact about it. During its final years of service, this bomber actually did a fantastic job operating as a heavy lift transport. It might be tempting to just toss the B-19 onto a list of the worst airplanes in the world. People might write it off as an expensive, useless toy that never should have been built in the first place. But in reality, this aircraft served as a fantastic testbed for rolling out the brand new technologies of the era. For example, the airplane featured an all-metal stressed skin construction. This meant the skin itself actually carried part of the structural load. Building a giant like this using older methods like internal bracing wires and fabric covering would have been flat out impossible. If the designers had stuck to the old ways, the payload capacity would have dropped to practically zero. Its top speed would have barely pushed 100 miles per hour instead of the 200 miles per hour it actually achieved. At the same time, looking back with the benefit of hindsight, it is pretty obvious. Massive, lumbering bombers like this would have been sitting ducks for fast interceptors and heavy anti-aircraft fire. Interestingly enough, the Soviets had a very similar project in the works. This was a super heavy bomber designed by Tupolev. It was known as the ANT-26 or the TB-6. This airplane was supposed to be even bigger than the American giant. It was designed to have a whopping 12 engines. It also had a massive wingspan of 95 meters, or about 311 feet. However, in 1936, the Soviet Union abruptly canceled the project. They took all that funding and redirected it into developing smaller tactical bombers like the XB-2. The American B-19, on the other hand, actually got its chance to fly. This was true even though they only ever built a single airframe. Back in the early 1930s, the U.S. Army Air Corps kicked off a massive modernization program. The military started replacing their obsolete B-2 Condor and Keystone biplane bombers. They replaced them with the new, genuinely groundbreaking Martin B-10. You could easily call this airplane the grandfather of just about every modern bomber flying today. But that brought up a pretty logical question. What exactly was the mission for these new airplanes? If they were flying directly out of the continental United States, the only targets they could realistically reach were in Canada and Mexico. And it is safe to say neither of those neighbors were exactly viewed as real threats to America at the time. To justify the massive price tag and the operational need for a new long-range bomber, Army leadership came up with an interesting argument. They argued that this kind of aircraft was absolutely necessary for coastal defense. It would be used to intercept an enemy fleet if someone tried to invade the continent. This was argued even though the chances of an amphibious assault like that were probably even lower than a war with their neighbors. On top of that, these bombers were supposedly meant to provide support for American military garrisons. These garrisons were stationed out in Alaska, Panama, and Hawaii. At the time, no one could really explain exactly how troops in those far-flung regions were going to fight. Nobody had any idea just how global the scale of the upcoming Second World War would actually be. Still, Congress ended up agreeing with the military brass. The politicians figured the country might actually need a powerful aircraft to support those remote bases. Because of this, in 1934, the War Department issued an official requirement for what they called Project A. The main requirement for this future bomber was pretty straightforward. It had to carry 2,000 pounds of bombs, it needed to cruise at 200 miles per hour, and it had to have a massive range of 5,000 miles. Bomb load and speed were not the issue. The main hurdle was range. 5,000 miles matched the absolute world record at the time, and that was for an aircraft flying completely empty. To fly that far, the bomber had to be absolutely massive. One option was to mount as many as 12 engines, like Soviet designers were planning to do. A much better and more logical solution was to use more powerful engines. But back then, power plants with that level of performance simply did not exist anywhere in the world. If the engineers at Pratt & Whitney had started developing their legendary R4360 Wasp major engine even 10 years earlier, aviation history would have taken a completely different path. But in reality, two projects were competing for the right to build the large bomber. These were the Boeing XB-15 and the Douglas Model 294. The XB-15 was designed as a four-engine aircraft. It was supposed to get the highly promising and incredibly powerful Allison V3420 engines. Essentially, each of these power plants consisted of two coupled V1710 engines. They produced 1,100 horsepower each, driving a single common propeller. But since these cutting-edge engines were not ready yet, in practice, the XB-15 actually flew with much weaker twin Wasp engines. These produced less than half of the planned power for the V3420. Douglas decided to raise the bar even higher. In January 1936, a special engineering team led by Schuyler Kleinhans finished the first blueprints for a true giant. It was the largest aircraft in the world at the time. The project, designated XBLR-2, was incredibly ambitious. It was supposed to be equipped with 6 powerful engines right out of the gate. Each would produce at least 2,000 horsepower. Prototypes for this kind of ultra-powerful engine were already being built by Wright Aeronautical. Their R3350 model, also known as the Duplex Cyclone, was a massive 18-cylinder radial engine. It seemed like the absolute perfect fit for this titan. However, in late 1937, the U.S. military and Douglas management agreed to scale down the size of the aircraft just a bit. They decided 4 of these engines would be more than enough. Along with the changes, the aircraft received a new, shorter designation. It was called the XB-19. By 1938, the War Department officially ordered the construction of this unique bomber. To build the XB-19, Douglas had to put up a gigantic hangar in Santa Monica. Standard facilities just were not going to cut it. Its massive wing set a new world record with a wingspan of 212 feet. Incredibly, it was manufactured as a single continuous piece. From an engineering and aerodynamic standpoint, it was a truly beautiful aircraft. Visually, it looked like a massively upscaled copy of the famous DC-3. But it had a much longer and more elegant wing. Each flap and aileron was almost 50 feet long. They were so huge that the designers had to split them into inner and outer sections. They connected them with special hinges. This was done to prevent any dangerous flexing of the metal in flight. Interestingly, the total wing area came out to 4,492 square feet. This was noticeably less than earlier giant aircraft. These included the Italian Caproni CA-90, the German Dornier Do-X, and the Soviet AN-T-20. However, those older models were aerodynamically dirty. In contrast, American engineers managed to create a perfectly smooth, modern cantilever wing. It was completely free of external struts or bracing wires. The fuselage on this bomber was really something else. It featured a massive, wide nose section. This smoothly tapered back into a surprisingly thin tail section. Looking at it, you would almost think that skinny tail could not possibly handle the immense aerodynamic loads. This was especially true since it carried the largest rudder of any aircraft built up to that point. The standard crew for this giant bomber was 10 men. The cockpit, where the pilots sat side by side, actually looked pretty bare by modern standards. What really caught your eye, though, was the large center console with its absolutely massive throttle quadrant. You would find a lot more instruments and gauges back at the flight engineer station. Located just a bit further aft, this compartment even had special crawlways. These led directly inside the thick wings, giving the crew in flight access to the engines. If things got hot, up to 8 crew members could man the gun stations to fend off enemy fighters. The defensive armament packed a serious punch. The nose and upper forward turrets housed 37mm cannons. These were made by the American Armaments Corporation. The rear upper turret featured a .50 caliber Browning machine gun. Meanwhile, 2 more manually operated .50 caliber guns were tucked right under the rudder. On top of that, the waist positions were armed with 2 more .50 caliber machine guns. They also had 2 twin .30 caliber machine guns. Inside, the bomber was incredibly bright and roomy thanks to its extensive glazing. This gave the crew plenty of space to work. But the real showstopper was the bomb bay. It completely outclassed every competitor of its day. It could be loaded with any of 14 standard ordnance configurations, For a mission out to about 2,000 miles, the airplane could haul a massive bomb load. This load weighed in at 37,100 pounds, and if they needed to fly an ultra-long-range mission, a fully fueled B-19 could cover an incredible 7,000 miles. It could do this while still carrying 1,500 pounds of bombs. Performance numbers like that were simply untouchable for any other airplane of the era. As you might guess, the secret behind this massive range came down to an enormous fuel capacity. And in this department, just like in so many others, the giant Douglas bomber set a brand new record. Its tanks could hold a staggering 9,160 gallons of aviation fuel. Just to give you an idea of the sheer scale here, that is roughly 50 times more fuel than a typical Royal Air Force bomber could carry back in the 1930s. This gigantic volume of fuel was stored inside integral light alloy tanks. These were built right into the wings. As a result, the maximum takeoff weight of this metal giant reached a jaw-dropping 164,000 pounds. That was almost double the empty weight of the aircraft, which was 82,253 pounds. Even with all four mighty engines running at absolute maximum takeoff power, the power loading was still 20.5 pounds per horsepower. To put that into perspective, that kind of power loading might have been borderline acceptable for a lightweight fabric-covered biplane. But for a heavy, cutting-edge monoplane, it was pushing the absolute limits of safety. Because of this, the engineers knew right from the design phase that a fully loaded B-19 would need an incredibly long takeoff roll just to get airborne. And once in the air, the bomber was going to be notoriously sluggish and heavy on the controls. Interestingly enough, the development of the B-19 bomber happened right around the time when tricycle landing gear was really starting to catch on in aviation. And you have to admit, the designers pulled the system off flawlessly. Each of the three gear struts had a single wheel, but the mains were absolutely massive. The entire gear assembly was fully retractable, powered by heavy-duty hydraulics. The nose gear folded straight back, tucking into a long wheel well enclosed by twin doors. Meanwhile, the main struts retracted straight up into the wings. This left the tires exposed and sitting flush with the lower wing surface. Decades later, you would see a very similar setup on the Boeing 737. Overall, a lot of the landing gear's design features borrowed heavily from the DC-4 prototype. Douglas was developing this aircraft at the exact same time. The heart of this giant was a set of four massive Wright R-3350 Cyclone 18 engines. They were housed in tightly fitted cowlings and mounted securely to that enormous wing. The cowlings were wrapped incredibly tight around the power plants. Since the structural framing was fixed, mechanics had to either reach in from the front or remove one of the 9 cowling panels to access the engine internals. Pulling off just one of these panels gave them direct access to 2 cylinder heads at a time. The cooling system was also engineered down to the last detail. Hot air exhausted through controllable cowl flaps. These were positioned completely around the trailing edge of the cowling. And to keep the engine oil cool, they used tubular oil coolers. These were tucked inside ducting just under the wing's leading edge. For the inboard engines, the intakes were placed closer to the fuselage. Meanwhile, on the outboards, they were pushed out closer to the wingtips. There was also a really unique engineering quirk here, though it was a feature they eventually scrapped. Each engine was mounted using 9 pairs of specialized shock absorbers to dampen vibration. These were bolted directly to the cylinder heads around the front ring of the nacelle. This created perfect dynamic balance. The aircraft was fitted with a few different types of 3-bladed props from big names like Hamilton Standard and Curtiss. Their size was genuinely massive. Prop diameters ranged from 15 feet 2 inches to well over 16 feet 6 inches. Unfortunately, the B-19 project looked like a pretty questionable gamble right from the start. As time went on, things only got worse, constantly setting the program back. Even while the first prototype was still being built, it was becoming increasingly obvious. This incredible aircraft would probably never see mass production. For one thing, aircraft engines with the kind of power this bomber required simply did not exist yet, and nobody expected them to hit the market anytime soon. For another, military strategists were starting to realize that building giant, highly vulnerable bombers was not exactly the best way to spend a defense budget. As a result, the massive bomber was knocked down to the lowest possible priority. On top of that, the company was hit with an unprecedented and completely unexpected demand for smaller, more practical aircraft. These were being ordered not by the dozen, but by the hundreds and even thousands by unexpected clients like Great Britain and France. Under these conditions, it was physically impossible for the manufacturer to stick to the original schedule. That schedule had slated the giant bomber's first flight for August of 1939. Internal company newsletters from April and June of 1940 were still optimistically promising that the long-awaited maiden flight would take place late this summer. There was another really fascinating detail in those documents. To oversee the assembly of the massive wing and fuselage, Douglas management made a surprising move. They actually brought in a team of engineers who had previously worked on the Golden Gate Bridge in San Francisco. Aircraft designer Sky Kleinhans later admitted he thought it was mostly just a clever PR stunt. Still, the sheer scale of the airplane was truly mind-boggling. The workers assembling the bomber actually had to wear metal hard hats. And that was not just some overzealous safety rule. It was to protect their heads in case a tool or a heavy part dropped from 50 feet up. In some spots, assembly was happening even higher than that. When World War II broke out, the priority for the massive project dropped even further. The company's Santa Monica plant was running around the clock, cranking out 20 Havoc bombers. So even when the giant B-19 was finally rolled out with great fanfare in February 1941, there was still a ton of painstaking testing left to iron out all the kinks. By that time, Army Air Corps Major Stanley Umstead had gotten to know this aluminum behemoth pretty well. He was chosen over the company's own test pilot to make the historic first flight. Fun fact, Douglas actually bought an insurance policy from Lloyd's of London to cover the airplane's full $1 million value. The crazy part is that the premium was absolutely astronomical just for the takeoff. But once the bomber safely got off the ground, the risk and the cost dropped significantly. The highly anticipated first flight finally happened on June 27, 1941. For a few incredibly tense seconds, it really looked like the insurance guys were going to have to pay out that million. As soon as the airspeed hit 75 to 80 miles an hour on the takeoff roll, Umstead pulled back on the yoke. At first, nothing happened, so he pulled back harder. Suddenly, the nose pitched up hard. But the real problem was that it just kept coming up. Within 2 or 3 seconds, the giant hit a terrifying deck angle. That angle would have stalled almost any aircraft in 1941, let alone a bomber with such a notoriously low power-to-weight ratio. As General Mark Bradley later recalled, they almost lost the airplane right then and there. Umstead later figured out the main quirk of the B-19. The flight controls responded perfectly fine, but with a massive lag. Basically, the airplane listened to the pilot, it just needed a little time to think about it. He later summed up the experience by saying you learned very quickly how to get out of a tight spot before you ever got into it. Later on, once the initial jitters wore off, many of the Army and Douglas pilots lucky enough to fly, it actually found the aircraft pretty pleasant to handle. Officially, it had a top speed of 209 miles an hour at altitude, but most actual flying was done at a much more relaxed cruise speed of around 170 miles an hour. Its service ceiling was a respectable 22,000 feet, and its landing speed stayed under 69 miles an hour. Even with that notorious control lag, the overall handling was surprisingly decent, and that is genuinely impressive when you consider the colossal size of the wings and tail section, not to mention the total lack of hydraulically boosted flight controls. When the first photos of this massive project hit the press in 1939, journalists instantly dubbed it an experimental bomber. The media was buzzing with speculation. Some enthusiastically praised it as the first bomber capable of flying across the ocean. Others claimed it was a flying battleship that would completely revolutionize strategic aviation. Then there were those who believed the aircraft was built strictly to gather flight data for an aircraft of that sheer size. There were even rumors going around that it was specifically pitched as a military bomber just to get the United States government to foot the bill, when the real goal all along was to build a giant transport plane. But beneath all the flashy headlines, everyone missed one simple fact. It truly was designed as a one-of-a-kind bomber with unprecedented range. However, as its complex development dragged on, the very concept of an aircraft like this became hopelessly obsolete. A new, much more capable generation of bombers was already on the way. It would soon take shape in the famous B-29. Ultimately, the early guesses from the press about it being a transport plane were not that far off. After just over a year of various and often underwhelming flight tests, the military actually started using the XB-19 as a heavy cargo transport. The aircraft went through an upgrade. It was fitted with new, more powerful IR-3350-11 radials. The entire airframe was also painted in a flat, olive-drab camouflage. Interestingly enough, the weight of the paint alone ate up several hundred pounds of its payload capacity. Throughout 1942, the giant worked tirelessly. It hauled military cargo across the United States. Back during its development in 1939, engineers made a proud claim. They said that instead of a bomb load, this massive aircraft could carry up to 215 fully equipped troops. In reality, though, it never once carried a troop complement. All the mounts for its defensive machine guns and cannons were prepped before its maiden flight. Even so, actual armament was never installed on this one-of-a-kind aircraft. You would think that during the hectic days of the war, the easiest thing to do would be to just scrap the XB-19. It could have easily been written off as a weird and totally impractical project. In reality, however, the giant had massive potential as a heavy lifter. Then, something unexpected happened. In early 1943, the military brass decided to pour some serious money into a complete overhaul. The plan was to rebuild the aircraft from nose to tail. This would turn it into the ultimate transport plane. To do this, engineers stripped out all the gun turrets. They also gutted the inside of the fuselage to free up as much space as possible for hauling cargo. On top of that, many of the onboard systems were heavily upgraded, including the radio gear. The old engines and their nacelles were completely removed. In their place, they finally installed the exact high-power engines that had been planned 7 years earlier but were not ready at the time. These were the Allison V3420 engines. These engines cranked out 2,600 horsepower each. Each power plant consisted of 2 V12 cylinder blocks. These drove a massive 4-blade Curtiss electric propeller. The diameter of those props was staggering, measuring a full 19 feet. Similar power plants were tested on a few other experimental aircraft, like the YB-29 and the XP-58. These new engines completely transformed the aircraft into a new variant, designated the XB-19A. The former bomber went on to become a true workhorse. It was a reliable, well-loved transport used for hauling outsized cargo. On the outside, the XB-19 was left unpainted in a bare metal finish. Only its wingtips and tail were painted bright red. After August 1945, it was simply no longer needed. Because of this, the massive aircraft rarely flew. Ultimately, its story came to an end in 1949. This was when the unique bomber was scrapped at Davis-Monthan Air Force Base.